Eric here with a kitchen chemistry demo. In this demo, we'll be doing the stoichiometry of sodium bicarbonate and acetic acid, which is just baking soda and vinegar. Here's what I'm going to use. Scale, a big tall glass, measuring cup, of course vinegar and baking soda, a small bowl and a spoon, notebook and pen, and last but not least, paper towels. Let's get going. Okay, you can see I've got my notebook set up. We'll be taking the cumulative mass, that is the mass of everything once we add in each additional item. You can see the big glass is 411 grams. Now I'm adding in the baking soda, and I previously weighed that. I was aiming between 10 and 15 grams. So we'll tally that in now. We're going to need to get the weight of the measuring cup too. So that tallies up to 805 grams. I'm going to use roughly a cup of vinegar. I want actually more than a cup. Mass-wise, a cup clocks in at 200 to 250 grams, depending on what substance you're talking about. You can see now the total system clocks in at 1,032 grams, or 1 kilogram plus 32 grams. Now I'm going to let the reaction happen. And that's pretty evident that there is a reaction going on there. I'm speeding up the video here because this entire process took about 3 to 4 minutes long, and I figure you don't need to see bubbles for 3 to 4 minutes. If you try to go too fast, it will overflow your container, as I found out a couple of different times when I messed this up. So going slow is the only way to go on this. And that, by the way, is the tallest glass I own for that reason. Eventually, though, you can get all the vinegar in. And I'm keeping the measuring cup right there on the system, letting it bubble out a bit more. But it's actually not done reacting. There's still, it's tough to see in this picture, but there's still some powder sitting down there. So we're going to stir it up, and that will help make sure that every last little bit reacts out. Now if you're looking at the scale, it reads 1028, but it's still bubbling. That means it's still producing gas. So as we stir this down, eventually it levels off. And we have 1,026 grams. Now it's time to jot down some observations from the reaction. So what did we observe? The signs that there was a reaction include, in this case, bubbles! Lots of bubbles. It's a pretty good indication that there's a reaction going on. And the final mass of the system, we record that as 1,026 grams. Okay, so that was the demonstration. Now let's take a look at the chemistry and see if we can explain what we just saw. So, what chemicals did we have? We had, for the reactants, we had sodium bicarbonate, otherwise known as baking soda. The chemical formula of that is NaHCO3. We had the vinegar, which is acetic acid, which clocks in at about 0.8 moles per liter. That might be interesting later on when you get to concentrations, just as sort of a quick reference mark. But anyway, so the chemical formula here can be a little confusing. Different teachers write it down differently. They all basically mean the same thing. I'm going to be sticking with this first one, HC2H3O2. Sort of depends on what background your teacher has and how they want to show you things. Next up, what was produced? Well, we saw the bubbles, which were carbon dioxide. I could have tested this by lighting a match and putting it in there, but, you know, it's CO2. All right, what else? Well, baking soda is a weak base. Vinegar, of course, the name gives us the clue that it is an acid. It's a weak acid. And when acid and base get together, it's a pretty safe bet that they will produce water. And so then what's left? Well, if we just sort of take a look, the CO2 is coming from the carbonate part of bicarbonate. And then the H2O is coming from an H, actually this H, and then some OH. And what we're left with is the sodium and the acetate. So the sodium acetate formula is NaC2H3O2. Okay, so now we've got a chemical equation. We need to check to see if this is balanced. So I show my kids, I use a chart. We just do this. We count up the sodiums we have on the left-hand side, just the 1. The hydrogens, 1, 1, plus another 3 gives us 5. Carbons, 3. And the oxygens, 3 plus 2 is 5. On the right-hand side, what do we have? 1 sodium, 1, 2, 3, 4, 5 hydrogens, 1, 2, 3 carbons, and 1, 2, 3, 4, 5 oxygens. So this one is actually balanced as written. We're good to go. So now what? If you're new to stoichiometry, this is the first time you're learning about this, here's a quick tip for you. Now that you're here, find moles. Whenever you don't know what to do in a chemical reaction or a problem or whatever, find moles. So, sodium bicarbonate. We have, from the video, the big glass was 411 grams. When we added the baking soda, we were up to 424 grams. So this means that we've got 13 grams of baking soda. Okay? So, the molar mass, NaHCO3, and then we break that down, we come up with 84 grams per mole. So if we take the grams and we divide it by the molar mass, we get 0.1548 moles. Now if you know your sig figs, you'll see I'm carrying extra sig figs. Do that with your work until you hit the end. Well, what can we do with this? Well, here's the thing. For every 1 mole of carbon dioxide that was created, we used up 1 mole of sodium bicarbonate. So if we used 0.158 moles of sodium bicarb, we created 0.1548 moles of carbon dioxide. Oh, so if we have the molar mass of carbon dioxide at 44 grams per mole, we take the molar mass, and this time we take the moles and multiply by the molar mass, we come up with 6.8 grams. So, does this match what we measured? Yes. The mass of the big glass plus the baking soda plus the measuring cup plus the vinegar was 1,032 grams. The mass after the reaction was done was 1,026 grams. That's a 6 gram difference. Now you're going to say, well, wait a second, 6 grams is not 6.8 grams. But you have to remember, I'm using a kitchen scale, and the precision of my scale is plus or minus 1 gram. So I think it's very safe to say that the 6.8 calculated is within the measured 6 plus or minus 1 gram. So that's a quick intro to stoichiometry, and the point of this was so that you can see that we can actually measure the mass of a gas that's being evolved as the mass that a system loses, and we can calculate that mass by doing stoichiometry just as well as measuring it. Thanks for watching.